So today I'm going to discuss the network intrusion detection system, which I built using a hybrid approach and which is a combination of CNN and CGAN network model. First of all, I would like to discuss a little bit the background in network intrusion detection. The network intrusion detection started with the vector machines algorithm, which was early used for the intrusion detection in for the various perspective in the networks. After that, it was a lot of limitations on these algorithms and wasn't enough for the intrusion detection later on. RNN, ANN, all the other methodology, which are the machine learning models, are used to implement the needs system. So the latest work which has already done was the CNN with combined with the LSTM, which is the main comparison of our research and the improvements and the gap between them. So what what was the background which I already discussed, the niche system, and yeah, the rapidly evolving landscape of cybersecurity threats prevents a significant challenge for the traditional network intrusion detection. To address this, project focused on investigating the issue of class imbalance. A lot of issue was creating in the net system, like the class imbalancing and for false negative response, because there were a lot of issue creating, like they were detecting minimum rate of detection of the attacks in the computer dataset and networks. For that purpose, a lot of network statuses already used. First of all, if we talk about the previous dataset, which is NSL KDD, and the other datasets are CIC 2017, which are used. And but in our research, we use the datasets from the University of Wales, UNS, and West University of Australia, which create who create our dataset. But there is a lack and gap between in this dataset was the class imbalancing, like the number of attacks and the number of the genuine data, the genuine like the data was the difference. There was a gap between them, so we need to imbalance. You need to remove this imbalancement between the real and the fake accounts, fake attacks, because whenever data sets are created, that's used for lab purpose or for network security improvements. So we need to pre-process data. For that purpose, we use CGAN, where a fake account was created, like augmentation. Data augmentation was done by the CGAN, where, whose purpose was to generate the fake multiple fake accounts attacks. When these attacks are created, then there was a class imbalance in the dataset. After that, we used the CNN to improve the accuracy and reduce the FNR. So the main objective of our research was to reduce FNR and improve accuracy. If I talk about the previous hybrid model, which was CNN with the combination of LSTM, they showed 94.45 accuracy, and there was a enhanced FNR, which was the main drawback, which was the main gap between previous research. So we tried to reduce the false negative response and also to improve the accuracy of the network intrusion detection system. So for that purpose, what was the project goals was pre-process the UNSW-NB15 dataset, which is provided by the and publicly available on the website of Western University of Australia. Then we design RCGAN to synthesize minority class attack data Later on, we train, like when we create, we have done with the data augmentation, CNN to on this augmented data set for to detect a number of attacks. Then we perform evaluation performance metrics like precision, recall, F1 score, and then in this paper we also compare our research with the previous one. Literature view already, I'm done with, like sport vector machines. Random forest was the first initial point in the intrusion detection system when they started to improve the the network system. They started with these algorithms, but they were not sufficient. They were not enough capable of to do to detect the fake account, to detect the attacks on the network. So I already mentioned CNN LSTM, which was the latest research has done in carried in 2024, where they improved detection accuracy, everything, but they were short in dealing with the balance imbalance data handling, which already explained that we improved this one using CGAN. If I talk about the previous, all the methods, never season model never been used before. That was the model we tried to implement, and we finally got the better results from the previous work has been done. A methodology we use already a little bit discussed, which was CNN and CGEN combination, and where our main focus was on minority attack classes using the UNSW dataset. So that's what's the methodology. Like we first of all we use CGAN model to generate augmented samples, which are then we applied, like when we generate the fake accounts in the data set, we remove the data imbalancement in the data set. Then we applied CNN to anomaly detection, intrusion detection. And so obviously there are two inputs to the CNN. One was the augmented data, which was done by the CGEN, and the other one was the data set, which is publicly available on university website. So we pre-process the data and give to the CNN. Another input was augmented samples, and then CNN was working as a model which used to detect the attack patterns and detect attacks, which significantly improves accuracy to 99.45. So that was the data pre-processing, which is mostly common for every data sets. What you need to do, improve the data sets. So, if I talk about training details, CGen trained for 2000 epochs, patch size 32 using Adam optimizer class condition label to generate synthetic attack samples. And then we trained for 20 epochs, patch size 64 with dropout and batch normalization on the augmenting dataset for the binary intrusion detection. What we achieved, performance overview of the CGAN augmented CNN model on the UNSW that set reportedly with accuracy 99.45%. That's the results which we got. Accuracy, precision, recall, class 1 true positive response rate, false alarm rate, false negative response, and rate, and true negative. So our main focus was to improve false negative rate, FNR response, so which have done and carried out through this results. So these are the results already shown on graphical representation of the table, which clearly mention everything T, P, R, T, N, R, F, N, R, and F, A, R. That's the confusion matrix, which obviously used to create like out of normal account. There was for example, there was normal uh, data, normal attacks, which was real one, and the fake generated sample. They were generated and detecting attacks 4 out of 4, 4, 4, 5, 30, and similar from the 36159, which was not detected, was 41, which is significantly improved than the previous research. That was the research objective as well. So these are the results and training validation on the graphs, and which show are continuous, because we get not only one epochs, we generate, we perform this for multiple epochs, and after every epochs we got results which are improved and better performance, with the better performance, and there is no overfitting, you can see on the graph. So we improved that model than the previous hybrid model with 99.45% accuracy, and outperformed the CNN LSTM based system. That's the comparison table between previous LSTM and by LSTM, and these are the datasets and applied on the same dataset. These model hybrid approach was performed on the same data set. So that's why we picked and chose this model to to enhance the not only the accuracy but also FNR. So that was all about our research article which we submitted, and that was work with done by us. So if you have any question regarding this, so you can ask.